In the next 20 minutes, we are going to understand what Node.js is and how it helps us build real backend applications in a very simple way. I'm Harshit and I'll be your mentor for this course. Most of you already know JavaScript, but usually we think JavaScript works only inside the browser. That's actually not true. Node.js allows JavaScript to run outside the browser, directly on a computer or a server. This means we can use JavaScript not just to design pages, but also to build servers, handle requests, and send responses. Node.js is not a new programming language, and it's not a framework either. It's a runtime environment. A runtime simply means it provides everything needed for JavaScript to run on a system. Before Node.js, developers had to use different languages for backend and frontend. For example, JavaScript for frontend and Java or PHP for the backend. Node.js made it simple and possible to use one language for both. This reduced the development time, made teams faster, and simplified the application architecture. This is one big reason why Node.js is so popular in the industry. Today, Node.js is commonly used to build APIs, backend services, real-time applications, and microservices. Many modern web applications rely on Node.js in some form. So in simple terms, Node.js lets us use JavaScript to create backend logic and servers instead of limiting it to browsers. In this course, we'll slowly build a small project while learning these concepts, so by the end, you'll clearly understand how a backend works. Now that we know what Node.js is, let's understand how it actually works behind the scenes. Most traditional backend systems create a new thread for every request. That means if 100 users send requests, the server tries to handle 100 threads at the same time. But Node.js works differently. It uses a single main thread. At first, this sounds like a problem. You might think, if there is only one thread, how can Node.js handle many users? The answer is that Node does not wait for slow tasks to finish. Whenever Node.js receives a request, it starts processing it. If the task is fast, it completes it immediately. If the task is slow, like reading a file or writing for a database, Node.js sends the task away and continues handling other requests. This is called non-blocking behavior. Node.js uses something called the event loop to keep track of all these tasks. The event loop checks which tasks are completed and executes their results when they are ready. Because of this approach, Node.js can handle thousands of users using very little system resource. This makes Node very efficient for APIs, chat applications, live updates, and real-time systems. So the key idea to remember is simple. Node.js does not do everything at once. It does things as soon as they are ready. Now that we understand how Node.js works internally, let's actually start using it. Every Node.js application starts as a simple project. A project is just a folder that contains our code and related configuration. In Node.js, there is always an entry file. This is the first file that Node.js runs when the application starts. Commonly, this file is named index.js or server.js. The name is not special. What matters is that Node.js starts execution from this file. To run a Node.js program, we use the terminal and tell which file to execute. Once the program starts, Node.js executes the code from top to bottom. If the file contains logic that keeps running, such as a server, the program stays alive. This is different from normal programs that start, finish, and exit. Node.js applications can keep running continuously to handle requests. So, at a very basic level, a Node.js project is a JavaScript file that runs continuously and performs backend tasks. In the next stages, we'll slowly turn this simple file into a real backend server. Now, let's actually write and run our first Node.js code. Don't worry, this is going to be very simple. First, we create a new folder for our project. I'll name it Node Tutorial 1. Let me redirect to the folder. I'll open VS Code. Here we go. Inside this folder, we create a file called index.js. Index.js. Done. This will be our entry file. Anything we write inside this file will be executed by Node.js. Let's start writing the most basic thing, that is printing a message. In Node.js, we use console.log to display a message. Let's say, hi, I'm Harshit. And to run this file, I'll open the terminal. Now, using the terminal, we run the file using the node command. Node index.js. Here we go. So when we run the file, Node.js executes the file line by line and shows the output. This confirms that JavaScript is running outside the browser. At this point, we have officially created and executed our first Node.js application. Now, before we build anything advanced, let's treat Node.js like normal JavaScript. I'm inside my index.js file. First, let me create a simple variable. Say const name equals Harshit, and let me print console.log the name. Let me try to run. Hope you remember node followed by the file name. Yeah, it prints. Here, I'm storing a value in a variable and printing it. While I run this file, Node.js executes it just like browser JavaScript. Now let's add another variable, say for example const age equals say 20. If age is greater than or equals say 16, console.log big boy, else console.log hey kiddo. Yeah, an exclamation. Now let me run this file. Yeah, Harshit big boy. Great. So this if condition checks a value and decides what to print. This logic is exactly the same as what you have used before. Now let's use a loop to repeat something. I'll add a loop here, say for loop, and for variable declaration the same goes. Let the counter variable starts with 0 and say if I let it repeat console.log. Let me have okay. See count. Yeah, that works. So if I run this file again, this loop runs 5 times and prints the count each time. So the important takeaway here is this. Node.js does not change JavaScript. It only changes where JavaScript runs. Once you're comfortable with basic logic like this, writing backend code becomes much easier. Now that we are comfortable writing JavaScript in Node.js, let's use this logic to respond to real users by creating a simple server. Now we are going to create a server using Node.js. First, I need to import the Node.js built-in HTTP module. This module already knows how to handle web requests. So let me create a variable HTTP equals require followed by the module's name HTTP. Here, require is used to bring the HTTP module into a file. Without this, Node.js wouldn't know how to create a server. Next, I'll create the server itself. Const server equals HTTP dot create server, and inside which we have an arrow function which takes two parameters rec and res. The create server creates a server. Inside it, we pass a function. This function runs every time a request comes to the server. Req stands for request. It contains information sent by the user. And res stands for response. We use it to send data back. Now let me send a message back to the browser. So to do that, res dot write, we type, hey, my first server. Let me terminate with semicolon. This line writes data into the response. After writing the response, we must end it. And to do so, res dot end of. Res dot end of tells Node.js that the response is complete. Without this, browser would keep waiting. Now the server exists, but it's not running it. We must tell it to listen on a port. Now let me do that. So server dot listen, give it a port number, say 3000, and it takes a function inside which we can just print a message, console.log server is running on port 3000. Okay, good. This line starts the server on port 3000. The function inside runs once the server starts successfully. So when I run this file using Node.js, the program keeps running. If I open the browser and go to localhost colon 3000, the browser sends a request. Let me show that. Here you can see that. So Node.js receives the request and runs this function and sends back the response we wrote. This is the simplest backend application you can build using Node.js. Writing servers like this works, but it can become complex very quickly. So next, we'll use a framework to simplify this. We just created a server using pure Node.js. It works, but as the application grows, this code becomes harder to manage. This is why frameworks exist. Express.js is a lightweight framework built on top of Node.js that makes server creation much easier. First, we need to install Express.js. So to do that, head to a terminal and type the following command init -y. This creates a configuration file, and then let's do install express npm install express. Now inside the index.js file, let's rewrite our server using express. So I will delete everything. Const express equals require express. Cool. Here we are importing the express library. Next, we create an express application. So I'll create an app equals express. Oh, this app represents a server. Now let's define a root. So to do that, app dot get. This defines a root, and it takes two parameters, request and response as usual, and it is an arrow function. Within the parenthesis, let me write something, res dot send off. This means when someone sends a get request to the root URL, send back this response. So within which I'll just like hi from express colon. Now let's finally start the server, and to start the server as usual we need a port. So to make it listen, I'll use the same port 3000, and similar way it takes an arrow function as well. And as usual I will console log express server is running on port 3000. Awesome. This starts the server just like before, but with much cleaner code. Okay, so let me just run the file. No index.js. Express server is running on port 3000. Now, when we open the browser and go to localhost 3000, we get the response from Express. Let me show that. So if I refresh the page, hi from Express, here we go. So Express helps us to focus on what the server should do instead of how it should do it. Now that we can create routes, let's see how Express handles different endpoints and data. So far, our Express server responds at one URL. Real applications usually have multiple routes. Let's add a couple of more so we understand how routing works. So here I will change the message it sends. Let it be the home page. This is the default route. Since we are having only the slash, next we will have another route, again app.get, and this one is for the about page, say about, and again it has two parameters, request and response, an arrow function within the parentheses. Let us send a text res.send of about page. I'll terminate semicolon, and then we'll have another route, say app.get, and let it be for the contact page. Again, two parameters, request and response. The arrow function. Let us send contact page. Each route handles a different request. So, whenever we open a URL, the browser sends a request. Express checks URL and calls the matching route. Inside the function, we use res to send a response back. This request response cycle is the core of backend development. Now let us see how the site works differently. Now let me rerun the server. Cool. And I will refresh it. It became the home page. Now if I change the URL to about, it takes the about page, and if I put contact, it displays the information for the contact page. Let us now see one important thing, that is sending structured data. Servers usually don't send plain text, they send data. So for that, let me create another route app.get, and let me call it for the users. And again, they have two parameters, request and response, and an arrow function. Here we go. And now we are going to send a JSON file. We have a curly braces, same name, colon, Arshad, role, colon, say mentor, and course, colon, note. Cool. So this sends data in a JSON format. Most APIs work exactly like this. Let's check it out. I'll just rerun the server. Okay. Now here back, I'll type users. Here we go. We got the JSON response from the backend. With this, you have built a working backend server. You now understand how Node.js runs, how Express simplifies servers, and how routes work. In the next part, we'll move closer to real applications by handling data and user input.